So just to let you know, I am recording now the session. What's recorded, guys, is only my screen. Even I know all of you have your video off, but even if you have it on, it will not record the videos. It will capture my screen mainly, and my voice and probably your voice in the system. I'm not sure. I don't play the entire video when I record it, so I'm not sure if it picks up your voice as well when you talk to me. But just be aware, guys. But anyway, we're only talking mathematics. We're not discussing any sensitive issues. It's a purely math session. All right. Mutually exclusive events. What do we mean by mutually exclusive events? We say two events are mutually exclusive if they cannot happen at the same time. So two events, A and B, are mutually exclusive if they cannot occur at the same time. I'm gonna give you some examples. Here's an example, guys. Randomly, event A. All right, randomly select a female student with blue eyes. That's event A. Randomly select a nursing student. That's event B. Are the two events, guys, mutually exclusive or not mutually exclusive? Remember, mutually exclusive means they cannot happen at the same time. What do you say about those two events? Oh, you guys said you cannot see what I'm writing, so let me just move it down. Yeah. So two events are mutually exclusive because they cannot happen at the same time. Here's my example. Randomly select a female student with blue eyes, that's event A. Randomly select a nursing major students, that's event B. What do you guys say about the events? Are they mutually exclusive or not mutually exclusive? And if not mutually exclusive, because they can happen at the same time. Can you find a female student who is a nursing major? If the answer is yes, that means they're not mutually exclusive. Okay, let me show you some more examples, guys, from the book. It's on page 162. So as I told you, I do prepare those guided notebook, guys, but I cannot put the entire book in there. So there's a summary of what you should know. So we always need to reference the book one way or another. Let's go through the list, guys, just to make sure we understand what mutually exclusive events. It's very likely, guys, you'll have a question on the test. I'll give you two events and ask you if they are mutually exclusive or not. Very easy to tell if you understand the definition. What do you think of number 7, for example? Can the two things here happen at the same time? Do you see that he gives you a signal that they can happen at the same time because there's an intersection, overlap? These events are not mutually exclusive. But look at number 8. Can these two events happen at the same times? Movies that are rated R cannot be movies that are rated PG-13 at the same time. So these are events mutually exclusive. And you can see there is no intersection in here. Let's look at some wording here. Number 9. Randomly select a female public school teacher. Randomly select a public school teacher who is 25 years old. What do you guys think? Mutually exclusive or not mutually exclusive?
Not.
Not. They can. They can happen at the same time. If they can happen at the same time, then you say they're not, because you can find a female public school teacher who is 25 years old. What about number 10? Select a student with a birthday in April and select the students with the birthday in May. Can you select the same students who has a birthday in April and May at the same time? That cannot happen. So that means these events are mutually exclusive. What about 11? Randomly selecting a person who is a Republican and randomly select a person who is a Democrat.
Mutually exclusive.
Yes, you cannot find a person who is a Democrat or Republican. That's against it. That's illegal to be in both parties. Can't just be in both. I think they'll do investigation, you know, just when you sign up for one party to find out whether you belong to the other, but that can't happen. All right, so this is what mutually exclusive events are. Just want to make sure you understand that. And now we're gonna go back, continue with the addition rule. This is the very much, you know, just one objective, and then we have a little one and we'll be done with this chapter. Addition rule of probability. I'm gonna explain the addition rule to you guys. There is a formula that we're gonna come up with, and then after that, you will see it's a very easy rule to apply. It's called the addition rule. The addition rule says the following. If you want to find the probability of an event A or event B, you will add you will do probability of A, then you do probability of B minus probability of A and B. And guys means together. Or means if you get A, you win. If you get B, you win. You don't have to get both in order to win. So that's what or means. So if I'll tell you do problem 2 or 3 on the assignment, if you do 2, you're good. If you do 3, you're good. If you do both, better, but one is sufficient enough. So that's what A or B. Let me show you an example in how this formula works. This is a sample space that has all the outcomes. I'm going to put some numbers there. Okay, this is your sample space. I'm going to make B to be this. Or A. We'll start with A. And I'm going to make B to be that. That's B. I'm going to ask you a few questions now. What is the probability of selecting a number that turns out to be in A? So if without looking, guys, you put your finger there, what's the likelihood that you pick a number in A? Can you help me find this probability? So what's the probability of A?
5 out of 10.
Okay, let's see. How many altogether do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You agree that the sample space has 12? That's a 12. That's the sample space, guys. S. The sample space is the set of all outcomes. Okay, you said 5 out of 12. That is correct now, because A has 1, 2, 3, 4, 5, 5 out of 12. Okay, now guys, can you help me find the probability of selecting a number that turns out to be in B? Denominator is the same, always a 12.
6 out of 12.
How many elements are there in B? 1, 2, 3, 4, 5, 6. Six out of 12. Okay. Now, I'd like you guys to find the probability for me. What's the probability of selecting a number that turns out to be in A and B at the same time? The intersection. What would that be, guys?
2 out of 12.
2 out of 12. Does everyone agree? It's 2 out of 12. All right, great. Because there are 2 in A and B. So A has 5. If I want to list A, guys, I can list them right here. A has 19, 1, 4, 7, and 2. And then I can list B as well and list A and B. Now, I wanted to do A or B for me. What's the probability of selecting a number? If it turns out in A, that's good. It turns out in B, that's good as well. Let's see how many are there. Remember, denominator is always 12 here. Okay, A or B, let's count them together. 1, 2, 3, 4, 5. Do I count the 4, 7 again or keep going now, guys?
Keep going.
You keep going. I cannot count the number. If I have you on the list, guys, let's say I'm taking attendance and I put your name twice. I cannot count your name twice, guys, because that's it's only one student. So I'm not supposed to count your name twice for just, to inflate, the number of students. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So probability of A or B is 9 over 12. Now I'd like you guys to look at the formula and see how the formula works. I could have used the formula here. Probability of A, watch, it's 5 over 12. Probability of B is 6 over 12. Probability of A and B is 2 over 12. Notice, guys, if I add 5 plus 6, what do I get? 11. And if I subtract the 2, what do I get? 9. So you could have used the formula to find the probability of A or B. So the formula is valid. Probability of A or B equals probability of A plus probability of B minus probability of A and B. That is the formula. This is called the addition rule. And this formula is used to find the probability of A or B. In order to use this formula, guys, you need to know this. You need to know probability of B, and you need to know probability of A and B. If you do know those 3, you can find the probability of A or B. Now, so that's the formula, guys. If the events are mutually exclusive, then probability of A or B equals probability of A plus probability of B only. I want you guys to think for a second and tell me why this is true.
Because A and B can't happen at the same time.
Do you guys agree with her statement? That is correct. Because A and B cannot happen at the same time. They have nothing in common. That means probability of A and B equal to 0. So when 2 events, that is correct. When 2 events are mutually exclusive, guys, let's say 2 events A and B. Probability of A and B equal to 0 because they have no intersection. And A and B is all about intersection. Okay, let's do an example for the addition rule. I have a couple examples for the addition rule.
I have a question about the last statement you just said.
Yes.
So I know they're not supposed to cross or something, but In the last example, A and B did cross like a little bit.
Yeah,
Or
but
they touch.
probability of A and B was not 0. It was, yes, they did. But look, probability of A and B was 2/12.
Oh, but if they're mutually exclusive.
If
you're
they
saying
are mutually exclusive, the example that I gave you is not for mutual, they're not mutually exclusive. Otherwise, you're correct, yes.
Okay.
Only if they are mutually exclusive. So if I give you, for example, this question on the test, I tell you A and B are mutually exclusive. Probability of A is 7/15. Probability of B is 3/15. What is the probability of A or B? You should be able to do it. 7 plus 3/15. No need to worry about probability of A and B because we know it's 0. He doesn't need to give it to you.
Okay.
Example, you roll a die. Find the probability of rolling a number less than 3 or rolling an odd number. Okay, if you want, since this, we can list all the outcomes. What are the possibility of rolling a number less than 3, guys? What could you get? You can roll 1 or roll what? 2. Rolling an odd number. What are the possible outcomes for odd numbers on the die? 1, 3, and what? 5. So what would be probability of, let's say, less than 3 or odd? Can someone give me the answer? If you want me to use the formula, I'll show you how to use the formula. How many outcomes do I have here? 2, right? 2 out of 6 plus. How many outcomes do I have for odd? 3 out of 6. Where do they overlap and how many outcomes do they overlap, guys?
1.
1, because there's a 1 here, watch, guys, and 1 here. It's 1/6. The answer is 4/6. Another way you could have done this, guys, combine the 2 together. 1, 2, 1, 3, 5, but don't repeat the 1 twice. So you'll have 1, 2, 3, 5. That's 4. 4 out of 6. That would be your answer. Okay, I'll give you a second to look at the next one and tell me what the answer is. So the frequency distribution shows the volume of sales in dollars and the number of months as sales represent reach its sales level during the past 3 years. If this sales pattern continues, what's the probability the sales representative will sell between 75,000 and 124,999? So actually we're talking here, guys. This or that. And how many total months do we have here? 3 years. So that should add up to 36 months, guys. Okay, any ideas? What would be the answer? Any input? We need, what's the probability that the person will sell between 75,000 and 124,999? So if he sells between 75,000 and 99,999, that's good. That's one of the numbers. So which is what? 7/36 plus
9/36.
9/36. Now minus, well, there is no overlap here. So these are mutually exclusive. Because you can see from 75,000 to 99,999, it doesn't overlap with 100,000 to 124. So that's the answer, 16/36. That will be your answer. This is the addition rule, guys. So it's either sales of 75,000 to 99,000 or sales of 100,000 to 124,999. So once I say the word or, you're talking addition. The only time, guys, where you do addition of probability is when you do an or, probability of A or B. Okay, so that's the addition rule. Okay, let's do one more exercise here on the addition rule. A blood bank catalogs the types of blood given by donors during the last 5 days. A donor is selected at random. What is the probability that the donor has type O or type A? Okay, according to the formula, guys, it's a probability of A plus probability of O minus probability of type A and O at the same time. Do you think it is possible for one of us to have type A and type O at the same time, guys?
No.
Not possible. The events are mutually exclusive. So we know this is going to be what? 0. Okay. What is the probability of A? What's the probability that we have a donor with type A?
164.
164 over. It's always over the denominator.
409.
409, exactly. Plus, what's the probability of selecting a donor that has a type O?
184.
184.
Over
And always say
409.
the denominator, 409. Okay, that's the answer. So I have a 348 divided by 409. That's the answer. Find the probability of a donor that has type B or negative. B or RH negative. Okay. According to the formula, guys, it is a probability of B plus probability of RH negative minus probability of B and RH negative. Okay, let's answer them together. What is the probability of selecting a donor that has type B?
45 out of
45
409.
or 409. That's not a very common blood type. That's my blood type, B minus. Okay, what's the probability of selecting someone who has a negative blood type? Yes, 65, it's right here. Minus, now you want to get rid of overlap. The minus, guys, is just to get rid of the overlapped data. That's the idea for it. Okay, how many are there that are B and type minus that we counted twice?
8.
So there, 8, exactly. Look, from here and from there, minus 8. As simple as that. So 45 plus 65 is 110 minus 8 is 102 over 409. You guys, did you see in part A that there was no overlapping? Watch. This is type A and this is type O. They cannot overlap because they're both vertical lines. In order for overlap to happen, you have to have a vertical line and a horizontal line. That's why we had a 0 there. There is no overlapping. All right. So this is another application. This is typical question probably you could see on the test with additional rule of probability. This is the addition rule of probability. You can use this example. All right. Let me ask you a part C here, unrelated to the addition rule. Find the probability that the donor has type AB and RH plus. What would be the answer? So we want someone who is AB and RH positive. Denominator doesn't change, guys. It's 409. How many are there who have type AB and they are AB plus?
Is it 12?
Yes, it is 12 indeed. Look, the Y12. Look, this is A positive and this is AB. So the answer is just 12. Now, why? Maybe you'll ask me, why didn't I use addition rule? Look, I put the word and here. I did and I didn't put or. If I did the word or, then I'll go through the entire formula. Okay. The last thing in this chapter, guys, and this is going to be quick anyway. Let me explain to you what this one is, and we'll be done with this chapter. Okay. Let's say I have 4 letters, A, B, C, D. I want to select 3 letters, any 3 letters, and the order is not important. In how many ways I can select 3 letters? Order is not important. So whether I select A, B, C, whether I do B before A, before C, it doesn't matter. It's the same thing. Can you guys help me list the possibilities here? Let's do it. Give me the possible ways I can pick. Let's say these are 4 students and I want to select the 3 students out of 4. How many different groups of students I can get? What would be the first one, guys?
ABC.
Good. That's one. Okay, give me another one.
BCD.
BCD, okay, that's another one.
ACD.
ACD, that's a third one. There's one more. Come on, guys. One more. You didn't list all of them. You're missing still one. See what we have in the chat. BCD, we already did that. ACD, CAD is the same thing as ACD. I said it doesn't matter. The order is not important here. So CAD is the same thing as ACD.
ABD.
ABD, exactly. There are 4 ways to do that. If the order is not important. You cannot say that BAD is a different combination. I said order is not important. As long as you get those 3 individuals, which one you pick first, it doesn't matter. That's when we say the order is not important. But guys, if I give you this on a test, you will hate me forever if I ask you to do this by hand. I give you those letters and I ask you in how many ways you can pick 3 individuals, groups of 3 individuals there. Do you think it's just gonna take as much time as we did with the 4? Do you know that this is gonna take a lot of time to do it? So there must be a formula that we can use to figure this out without going through this. The reason why I took you through it, because I want to show you how it works, and then I'm going to show you the formula. So there is a formula. I'm going to introduce this formula to you, and I'm going to show you that we're going to answer this one. I have how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In how many ways we can choose 3 letters? Order is not important again. This one, guys, could take you half an hour to figure it out by hand, but with the formula, it's going to take 5 seconds. You will see that in a second. So let me introduce this formula to you guys. It's called N choose R. N is how many we have originally, which is 4 in here. And R is how many in the group, which is 3. So it's 4 choose 3. Here's how the formula works, guys. And I'll explain everything in the formula in the second. Let me tell you what this simple, this is not an exclamation mark. It's called factorial. Let me tell you what it means. If someone asks you to find 5 factorial, it means 1 times 2 times 3 times 4 times 5. That's what a 5 factorial is, which is 120. If someone asks you to do 3 factorial, it's 1 times 2 times 3, which is 6. If someone asks you to do 2 factorial, which is 1 times 2, it turns out to be 2. 1 factorial, guys, is 1, and 0 factorial also is 1. So this is what a factorial is. Your calculator is capable of finding this factorial, and I'm going to show you how this is done. All right, watch, guys. This is how you find a factorial on the calculator. Let's say I want to do 8 factorial. You put 8. You don't need to go and multiply 8 by 7 by 6 by 5 by 4. I mean, you could do that, but that's going to take you a lot of time to get it done. So look how you can do this in one shot. You go to math, and I will provide the details of the calculator for this chapter as well. So that's math. You go to probability, and you can see the simple right there. It's number 4, guys. And 8 factorial, just press enter. There you go. It's 40,320. This is only 8 factorial. If you multiply 1 by 2, by 3, by 4, by 5, by 6, by 7, by 8, look what you get. So imagine trying to find 15 factorial. If I put 15 here, I'll go to math. I'll go to probability. Oops. And then number 4. Enter. Oh, can you read this number? It's 1.3076 E12 toward the end. E12 means, guys, you have to move the decimal point 12 digits to the right. So it's a huge number that it's very hard to read. It's in the billions. Okay. So this is the formula. And let me show you how we could have done this one. The answer was 4 using the formula. So 4 choose 3. It would have been, according to the formula, is 4 factorial over R, which is the 3 factorial, and 4 minus 3 factorial. I can do this by hand, and then I'm going to show you how to use a formula to do this. Okay, 4 factorial, guys, is 1 times 2 times 3 times 4. 3 factorial is 1 times 2 times 3. What is 4 minus 3? 4 minus 3 is 1, and what's 1 factorial is 1. Okay. 2 cancels out with 2, 3 cancels out with 3, so 4 divided by 1 is 4, and here you go, the answer is 4. Now, we could have done this using the calculator 4 choose 3, And let me show you how to use the calculator to do that. Okay, if you have your calculator handy, have it ready, and then I'll show you how to demonstrate this. Just on the home screen, you put 4. Then go to math. Then go to probability. Which is right here. Then you can see number 3, guys. It says NCR. This is the formula that I gave you. So NCR. Now the calculator wants the value of R, which is 3. Oh, the 4 we're trying to find. I have a question. Where did I get the 4 from? The 4 is I have 4 letters here, and we need to choose 3 letters. So you put 4 and then C3, and that's what I did. So it's the example that we did earlier. And then, guys, you just press enter, and you should not be surprised. The answer is going to be 4. That's a 4. Now, let me go and do the one that I told you about here. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, and want to choose 3. That's going to be huge. Watch. Put 15 on the home screen. Go to math. Number, probability. And put a 3. And look what the answer is. 455. I would never have you do this by hand because you were supposed to find 455 ways of doing this by hand. So that's not realistic to do anything like this by hand. So 15C3 is 455. Okay. Let me show you why this NCR thing is important. Any questions? I cannot hear you here. Your voice is not clear. Put it in the text and then I'll reply. Okay, let me go back here. And just write the combination formula. The formula here is NCR, and it is N factor. You don't need to do the formula by hand, guys, but I just thought to put it down. You can use the calculator always. And that's the formula. And this is when, without regard to order is not important. When the order is important, it's a different story. I'm going to give you another example. But before I give you another example, let's talk about the lottery and the Powerball. If you want to see what's the chance of winning, we're going to go over it right now. Okay. For the Powerball, you draw 5 numbers. Then you draw 1. It's for the Powerball. Okay. The 5 numbers, it's been a while since I last played. I think you guys, you get a 5 out of 69. Is that true? Does anyone play? You have to pick 5 out of 69. Does anyone remember? If not, I'm just going to make up, but I think it's 5 out of 69. So you select. So the first of all, you have to choose 5 out of. So I want to show you all the possible combinations that you can have for the lottery. So first of all, it's you have 69 numbers, and you have to select 5. Then the Powerball. Does anyone know exactly how many are there for the Powerball? Out of how many? Is it 27? I don't recall. So it's probably 27, and then you have to select 1. I'm gonna multiply those 2 things together, guys, and show you how many tickets you have to buy in order to win this. 69, choose 5. Let's do it together. So you put 69 on the screen, you go to math, probability, NCR, 5. Okay, this is the first number. Then you have the Powerball, which is, let's do it and then we'll multiply the two numbers. 27, choose 1. Math, probability, NCR, and then 1. 27 times 1, 1, 2, 3, 8, 5, 1, 3. These are all the tickets, guys, that are possible for the lottery. It's a 303,439,851. Since there is only a one winning ticket, a one combination that's gonna win, so the chance of winning will be this. 1 divided by 303,439,851. And let's write this down. It says E-9. E-9 means you have to move the decimal place 9 digits to the left. So your chance of winning, guys, that's why I usually don't play. That's the chance of winning. It's 0.00000003. Why people play? Because of the 3 here. Because it's not exactly 0. So there is a chance, but the likelihood that someone would win is very, very slim. That is the probability of winning the lottery. Any questions here? Okay, what about, this is the part for combination. There's one more thing and we'll be done with this lesson, is permutations. What do we mean by permutation? Is when the order is important. Let me give you this example, guys. It's a good example to introduce permutations. I have a table that seats 10 people. Let's do 10 chairs here. 1, 2, 3, 8, 9, and 10. So we have a people that seats 10 people, a table that seats 10 people. You invited 9 guests to your house and you want to seat them around the table. In how many ways this can be done? How many different ways that people can be seated around the table? Now, seating the order is important. It is important who sits next to who. So that's, we're making a criteria here that I want the order to be important. Otherwise, if the order is not important who sits where, then the number of ways to seat people is 1. Anyone can sit anywhere, and it's so anywhere. All those 10 people, 9 guests, along with the host, are gonna sit around the table. So it's just one way. But when the order is important, guys, you're gonna be surprised of how many ways. Can you give me some guesses? What do you think? How many ways are there to seat 10 people around a table of 10? Just give me some guess numbers and how many ways we can do that.
Would it be 10 different ways?
Okay, here's a 10. What else? Two ways.
Isn't it if each person has 10 possibilities? So
give me a guess. Give me a guess. Altogether, how many? 1,000, 100, million? 5 ways.
100 ways?
100 ways. One more. 3 million ways. Oh, Miriam, 3 million. Oh, do you think she's exaggerating? You think that's too much? I have a student who said, okay, you think this is too much? All right. Wait and see. It's a lot, guys. You can spend the rest of your life trying to figure out how many ways you can seat 10 people, and you will never get it done because there are so many ways. Now the question is, can I convince you? Well, I will convince you. Watch. You're gonna see how many ways. Actually, probably the 3 million is not exaggerated. Okay, the first guest arrives. The table is empty. How many choices does the first guest have, guys? So please help me answer those questions in order to get it done. So the first guest arrives, the table is empty. He or she can sit anywhere. How many ways does that guest have?
10.
10, exactly. Okay. That guest is seated and he could have sat anywhere he wanted. So he has 10 choices. The next person arrives. How many choices does the next person have?
9.
9. There are 2 seats are being occupied. The third person arrives. How many choices does he or she have?
8.
8. You guys see what's happening? 7, 6, 5, 4, 3, 2. Poor host. The host has no choice but to sit on the seat that is vacant. Do you guys agree? Once the 9 people are seated, the host doesn't have any choices, only one choice. It's 1. And remember, in order to figure, when you have so many events, here we have 10 events happening at the same time because I have 10 guests. In order to figure out the number of ways things can be done, we multiply the events. So we're gonna multiply 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 10 factorial, guys. And let me show you what 10 factorial is. Ready for the surprise? 10. And then go to factorial, math. So Miriam was very close. There are 3,628,800 ways to seat 10 people around a table of 10. Probably you'll tell me, who cares who sits next to who? I'm not gonna worry about it. But if you wanna worry about it, there's about 4 million ways of seating 10 people around a table of 10. So imagine if this was 15 people or table that seats 20, it will be in the billions of ways to do this. Okay, so this is when order is important. If the order was not important, guys, it would have been 10 C10. It will be the answer 1 way to seat people around a table of 10. So permutations, I'm gonna introduce this, the last thing. Permutation of n objects taken R at the time. It's a number of different ways when the order is important. So when order is important here. And here is the formula. It's NPR. And it is n factorial divided by n minus r factorial. This is called factorial. If I want to go to my example, it would have been, guys, 10 P10. You have table that seats 10, and I want to seat 10 people. In how many ways? Watch, guys. According to the formula, it would have been 10 factorial. 10 minus 10 factorial is 0 factorial. And that would have been, let's use the formula. It's going to be the answer that I got earlier, but let me show you that I could have used the formula here. So put 10 on the home screen to begin with. Go to math. Probability, and you see the MPR is number 2, guys. So the difference between 2 and 3, P is when order is important and C when order is not important. And let's put 10 here. And I should get the 3,600,000. I don't remember what was the number. 628,000. Watch, guys. Match. 3,628,800. Let's do this example here. 43 race cars started the 2007 Daytona 500. How many ways can the cars finish first, second, and third? Is the order important here, guys? What do you think?
Yeah.
Yeah, because it's a race. It's very important who finished first, second, and third. So it's a yes. Once you see a yes, then it's not a C, it's a P. Okay, we have 43 race, so 43, that's the number to start with. Instead of P and C, you have to put P because the order is important. And I have 3 places here, so it will be 3. Let's do the answer. You put 43 to begin with. Math, probability, NPR, and then 3, and get the answer. 74,046 ways. All right, so let me see here. This is very much everything that you need to know in this chapter. What time do we have now? Okay. These are some exercises, practice exercises. I'd like you guys to make sure that you can do number 9 very. So number 9 is an important question because it uses table. Make sure to do it, and then probably if you guys show up to office hours, but I'll make the solution available, you know, to this handout as well. I'm just gonna allow some time to go through the practice test with you, but I wanna go through a few questions with you here. Let's do number 1, for example. What's the probability of throwing 1 dice and getting a number greater than 4?
2 out of 6.
Yeah, greater than 4. What are the possible greater? You get 5 or 6, so there's 2 out of 6. These are the favorable outcomes, and these are the possible outcomes. As simple as that. What's the probability of throwing 2 dice and getting the sum of the fallen numbers greater? Let me change this one. That's too much to greater than 9. Okay. What are the sums that are possible that are greater than 9? On the 2 dice, guys, what kind of sums you could get? You could get as low as 2 and as high as what? What could be the highest sum on 2 dice? You could get 6 and 6, 12. So more than 9, you need 10, 11, or 12. Can you guys give me the order pairs that will give me a 10? What are the order pairs that will give me a 10? 4 and 6.
6 and 4.
6 and 4.
5 and 5.
5 and 5. Okay. Now an 11. 5 and 6. 6 and 5. Anything else? That's it. What about 12?
6 and 6.
That's it. Okay. It's out of 36 because we're doing 2 dice, guys. 6 times 6. So the answer is out of 36. And how many order pairs I have? 1, 2, 3, 4, 5, 6. The answer is 6 out of 36. What's the probability of flipping a coin and getting a head falling 5 times in a row? That's very low probability. How would you do this? We're doing the events 5 times, guys. So we have to have 5, multiply 5 probabilities. We're doing it 5 times. 1, 2, 3, 4, 5. What's the probability of getting ahead, guys?
1 and 2.
Okay. And it's going to be the same. These are independent events. It's going to be the same for all. So I got 1 out of 32 altogether. You want to figure out what 1 out of 32, if he asks you to do a decimal? 1 divided by 32 is 0.03125. So it's very unlikely to happen, guys. For your information, if a probability is less than 5%, it's called unusual. If it is 5% or more, it is usual. So anything that is less than 5% is unusual. Let's do number 6. We have 100 tickets in a hat numbered from 1 to 100. What's the probability that we pull out a ticket that is divisible by 5? So 100 tickets at the bottom. Now you would win if you get a ticket number that is divisible by 5. So you guys need to figure out how many numbers between 1 and 100 are divisible by 5. Can you tell me what they are? We need to list them actually. Okay, from 1 to 100, guys, what are the numbers that are divisible by 5? Any number that ends with 5 and a 0. So between 1 and 10, we have 5 and 10. Then 15 and 20. Then 25 and 30. Then 35 and 40. Then 45 and 50. Then 55 and 60. Then 65 and 70. Then 75 and 80. 85 and 90, 95 and 100, guys. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, 20. Answer will be 20 over 100, and so on and so forth. And for number 9, this is an application to what we did in the entire chapter. Do this exercise and I will provide the answers later. I'm going to stop sharing the screen and move you to the practice test and show you how the practice test works. Any questions? All right. Let's do this.